The fundamental differences between modern scanning technology and digital cameras are explained in this video. By the end of this video, the viewer will understand not only how the different technologies work, but will also be able to select the right equipment for a digitization project. So let's get started with some basics. How does the human eye work? The human eye is sensitive to three different colors called the primary colors. They are red, green, and blue. You can recreate any color visible to the human eye by capturing the intensity of these primary colors. How can we capture the three primary colors? There are different technologies that can be used, but all digital technologies have one thing in common. They consist of an array of light-sensitive elements called pixels, which will be exposed to the image of the object. When these light-sensitive pixels are covered with a color filter, some pixels capture red, green and blue light, but no pixels can capture all colors. A trilinear sensor is used in almost all scanners. This specific sensor has 7,500 red, green and blue sensitive pixels aligned in 3 lines side by side. Some scanners need a 4th line without a color filter to speed up scanning in grayscale because of their slow hardware. How does a scanner actually work? Scanners are used if the image of an object to be scanned does not change during the scan. Either the object is moved under the scan line, or the scan line is moved over the object. The document width that a scanner can capture is limited by the size of the sensor, but is unlimited in length by design. Scanners scan an image line by line and capture the image in all 3 primary colors, red, green and blue. Let's see how an image is captured by a scanner. In this example we have the character, H, followed by a dot in light gray on a white background. Line by line, the intensity of the image is captured by the red, green and blue channels simultaneously. At the end of the process we have 3 image planes, one for each color, and they are all in full resolution. In the next step, the red, green and blue image planes are combined into an 24-bit RGB plane, and the correct image of the original is restored. This is the basic technology used by all scanner vendors, whether they scan small or large documents, artwork, fabrics or anything else that does not change during the scanning process. Scanning technology is also used in sheet feed scanners, flatbed and overhead scanners. Can a digital camera substitute a real scanner? If you want the best quality, the answer is no, because of the severe limitations digital cameras have. Nevertheless, a few vendors use digital cameras to take pictures of a book instead of making a real scan. They still call these products book scanners, although they should correctly be called book cameras. It may sound like nitpicking, but there are fundamental differences, which need to be understood by a customer before the decision is made, whether the limited quality of a digital camera can deliver the quality needed for a customer's digitization project. Technology of digital cameras. Digital cameras have a fixed size of pixels, and since all the color-sensitive pixels need to be oriented side by side, they use an array of red, green and blue sensitive pixels in a mosaic, called a Bayer pattern. It is worth noting that the number of green pixels is twice the number of red or blue pixels. This is based on the fact that our eye is more sensitive to green than to red and blue. Evolution shaped our vision, and humans gained a leading edge while living in the green environments of forests for millions of years. Fast forward to today's technology and its differences. Let's have a look at how a camera takes a picture. The Bayer pattern interpolation. We will start with the character, H, followed by a dot, on an 8x8 pixel array. The Bayer pattern covered pixels are exposed like this. since all the color-sensitive pixels are side by side, there is no way to accurately capture the values of all three colors of an individual pixel. A process called interpolation is applied, which basically adds the two missing color informations to each pixel. This is accomplished by averaging the color values of the neighboring pixels. After this step, some super technical demosaicing algorithms are applied, which most vendors consider a technology secret. Note that whatever you do, some details of the image will get lost with interpolation. Remember, this did not happen to our scan. Is interpolation really so bad? Let's see how it plays out on a less detailed original. This 36-pixel large gray square on a 64-pixel white background will be captured like this. After the first step of bilinear interpolation, special smoothing algorithms are applied. The original is recognizable, although the edges are fuzzy. Compare this to the results of a real scan, performed with a trilinear sensor. A crisp, sharp and detailed image is the result of a scan with the same resolution. More differences between a scanner and a camera. As we can see, the size of a Bayer sensor needs to be a lot bigger than the size of a trilinear sensor with the same amount of pixels across. The Bayer sensor also needs a bigger lens than the linear sensor. In addition, the lens must also be of high quality in all directions, while the lens for a linear sensor can be turned in a way that only the best area across the center is used. Consequently, digital cameras are way more expensive than scanner cameras, as long as they have identical resolution and pixel size. How much resolution do we get? A typical 70-megapixel digital camera has 35 million green and 17.5 million red and blue pixels. In comparison, a typical image access book scanner has 7,500 pixels across and scans 10,000 lines. If we count the pixels the same way digital cameras do, this would be equal to a 225-megapixel camera. Now let us compare real-world pictures to real scans. A picture of this company logo has three color planes, red, green and blue. After they are interpolated and cleaned with content-changing algorithms, the result looks like this. A scanner first scans all red pixels, adds the green pixels to it, followed by the blue pixels to form the final image without interpolation, and with very few artifacts. Both images have the same resolution, and at first glance they look pretty similar. In reality, they differ a lot, in quality and sharpness as can be seen if enlarged. Conclusion. Use the right technology. Digital cameras are designed to take nice pictures. Scanners are designed to accurately scan documents. Thank you for taking the time to watch this video.